everyone, so now we're going to be talking about how to solve exponential equations. This is actually pretty easy as long as you feel really comfortable with exponents. So we're just going to get started with the first example, which is 5 to the power of 1 minus x is equal to 5 to the power of 2x. So the cool news about this is when we solve exponential equations, that means the x is inside the exponent. We can't necessarily solve it with the x in the exponent, so we've got to pull the x down. The way that we're going to pull the x down is to get rid of these base numbers, which are the bigger numbers. And it's really easy to get rid of these as long as they're the same number. So in this case, because these base numbers are both 5s, they actually cancel each other out. We cancel this 5 out, we cancel this 5 out, which just leaves me with my exponents. So 1 minus x is equal to 2x, and now we can solve that like a normal equation. So to solve that for like a normal equation, we're going to add x to each side just to get the x's on the same side. We would end up, these x's cancel out, we'd end up with 1 is equal to 2x plus x, which gives me 3x. Then I still want to get x by itself, so I'm going to divide each side by 3. We'd end up with 1/3 is equal to x. And that's my answer. X is equal to 1/3. We could potentially plug that back in to double check it, but I'm going to tell you it's right. Okay, so that was easy because those base numbers were the same, but what happens when the base numbers aren't the same? Like in example 2, so we have 81 to the power of x is equal to 1/3. What we want to do on here is we actually want to make sure or get these base numbers to be the same in the way with exponents. So I'm going to change both of these numbers, the 81 and the 1/3, to be 3s. The way I'm going to do that is I know that 81 is the same thing as 3 to the power of 4. So you have to use exponents to do this. You have to compare it with numbers and exponents. So I know 81 is equal to 3 to the 4th. I also know that 1/3 is equal to 3 to the power of -1. Because remember, if I pull that 3 back up above on the top of the fraction, I can make it to the -1. We don't like negative exponents like I've told you in previous videos, but for this one, we can change it to be negative exponents just so we can solve a little bit easier. So now that I have these two pieces of information, what I can do is actually replace the 81 and the 1/3 with the 3 to the powers. So I'm going to replace the 81 with 3 to the 4th, which gives me 3 to the 4th to the x, because this x right here didn't necessarily go away with the 81, it stays there. So we leave that there, but we just change the 81 to be 3 to the 4th. And then the 1/3 changes to 3 to the -1 power. All right, and then with the parentheses, we're going to just multiply those two exponents. So I'm going to end up with 3 to the power of 4x is equal to 3 to the power of -1. Okay, now it looks really similar to that first example because now you have the same base numbers. Because we have the same base numbers, they cancel each other out, which just leaves me with the exponents of 4x is equal to -1. All right, and now we're going to divide, or to solve for x, we divide each side by 4. The 4's cancel out right here. We're just left with x, and the -1 divided by 4 you can leave as -1/4. So my answer is x is equal to -1/4. Okay, let's look at another example. This example is 4 to the power of 2x times 4 to the power of 2 is equal to 4 to the power of 3x. So this time we have to use some rules of exponents like in the first video from this lesson. Use the product rule before we can actually start. So, because in order to cancel out each base number, you only can have one base number on each side. So we can't have 2 4s over on the left side and cancel them out. But with the product rule, we know when we multiply something with the same base, we add the exponent. So I can rewrite this as 4 to the power of 2x plus 2. I'm just adding those two exponents, the 2x right there and the 2 right there, is equal to 4 to the power of 3x. Now, because I only have one base number on each side, I can cancel those base numbers out, and I'm left with 2x plus 2 is equal to 3x. And I can solve that. I'm going to get the x's on the same side, so I'm going to subtract 2x from each side. The 2x's cancel out over here. We're left with 2. 3x minus 2x gives me just x, so I know that x is equal to 2. All right, let's go through one more example. So we've got 25 to the power of -3x times 625 to the power of negative 3x equals 5 to the power of 4. So this one, like in the third example, we want to combine them so you only have one base number on each side. But in order to combine them, you need the base numbers to be the same. So we're going to use exponents to deal with this. And I'm going to change everything to be powers of 5. So I know that 25 is equal to 5 squared. I also know that 625 is equal to 5 to the 4th power. And this is a lot of guessing and checking if you don't already know these numbers. Totally fine, just grab a calculator and start guessing. So what I'm going to do is change the 25 to be 5 squared, but I leave that negative 3x there. And then I'm going to change the 625 to be 5 to the 4th, and I leave the negative 3x there as well. And then that 5 to the 4th just stays 5 to the 4th over on the right side of the equal sign. So when I simplify that, I'm going to end up with 5 to the power of negative 6x, because 2 times negative 3x gives me negative 6x, times 5 to the power of negative 12x, because 4 times negative 3x gives me negative 12x, is equal to 5 to the power of 4. Because now they're all 5s, I can combine those terms using the product rule on the left side by adding the exponents. So it's going to be 5 to the power of negative 6x minus 12x. It would be plus negative 12x, but we can just write minus 12x equals 5 to the 4th. When I simplify that, I end up with 5 to the power of negative 18x is equal to 5 to the 4th. Now they have the same base numbers on each side, and there's only one on each side, so we can cancel those 5s out. We're left with negative 18x is equal to 4. Then to solve it, I'm going to divide each side by negative 18. The 18s cancel out over here. We're left with x is equal to negative 4 over 18, which can simplify to be x is equal to negative 2 over 9. And this is my answer. That's how we solve exponential equations.